Good morning, YouTube. Happy Saturday, everybody. I've been trying for about 10 or 15 minutes to get connected, and then on top of it, my PDF viewer crashed. So this is not running smoothly at the moment. All right, so I'm Greg from GregsTutoringNYC at gmail.com. My email is in the corner up there. As some of you guys know, I specialize in specialized tests. And at this point, we're talking about SHSAT-like ISEE examples. The ISEE is a test taken for a lot of private schools, and some of the upper grade questions are very close to what some of the SHSAT questions are. And we're at the point in the test where the questions are hard enough that they're really SHSAT 9 level questions. For those of you who kind of been waiting for this, you're going to be taking the SHSAT 9. Here we are. For some of these examples. As I've said either way, if you're in grade 9, you should still be doing all the grade 8 examples because that's part of the SHSAT 9 test. And if you're grade 8, because they can be giving some harder questions, you should also be doing the grade 9 examples. So in other words, whether you're taking the SHSAT 8 or the SHSAT 9, you should all be doing all the examples. Okay? All right. So let me get this back because I said my PDF viewer crashed. So let me try to get the file back up, and we'll just start off from where we left off the last time. This is like the 16th part of a series, something like that, and we'll just go with that. All right, so let me move this over here. In fact, I can move that slightly over because that often gets cut off in the process. All right, so again, so we're at a question here. Let me bring it up on mine. So let me just make sure the stream is running. Yes, we're good. Okay, great. Wait, just give me a warning. I don't know why it's doing this. I have FiOS, which YouTube should not be having a problem with. All right, okay, looks like we're okay now. The warning popped off. All right, so we're up to question 16, which is which expression is equivalent to the expression x minus 2 times x plus 3. All right, so this kind of question normally has a few parts to it. Sometimes it's just as simple as testing your knowledge of what this thing is even about, and that's really what this question is. Now, the SHSAT versions of this kind of question is usually harder, but sometimes the SHSAT just straight out asks you what something is. So this is normally considered a grade 9 problem. Okay, so make sure you're copying correctly, and don't do this kind of problem in your head. Okay, so I keep mentioning I have mild dyslexia, and I don't see things the same all the time. In fact, I was helping a student this morning, and I copied a number wrong and had no perception that I did so until I went to double check it. So I would have given the student the wrong example. So whether you have full dyslexia, mild dyslexia, or you're just a test taker, you need to make sure you're getting this right. So what we're going to do is run through FOIL, first, outer, inner, last. So we're going to do the two first ones. We're going to multiply them and get x squared. We're going to do the outer one. We're going to get 3x. We're going to do the inner one, get minus 2x. And then we're going to do the two last ones and get minus 6. Remember, your signs are important here. This just becomes itself, this is itself, and these two become x. Okay? So this one wasn't so hard, and we should be getting D. Okay? So again, it's tempting when it's this simple to do it in your head. Don't do it. If you don't know what FOIL is and you're taking the grade 9 test, definitely make sure that you find out how to do this. This is just a strategy. At the end of the day, what we're doing is taking each term and multiplying it by all the other terms. So we're taking x and multiplying by this term and this term, and we're taking minus 2 and multiplying by that term and that term. Okay, that's really all what FOIL is about. FOIL is a convention. It's not a mathematical formula. It's just an easy way to remember how to solve problems like this. All right? Okay. And again, And if you're in grade 8, you don't need to know this for the SHSAT, but as we always say, there's no guarantees. And if you know how to do it, sometimes there's a grade 8 problem that has an alternative solution that where you could use this, even if it's just to double check it. Okay? So again, it's in your best interest. If you're in grade 9, you definitely need to know this. And if you're taking the grade 8 SHSAT, you probably want to know this. All right? Okay, so question 17. So we're just going to look at the figure first. So we have an xy coordinate going from 6 on each side, 6 plus 6 minus 6. And we have a line that crosses the upper y-axis and the right-hand side x-axis. So it's in positive territory on both of them. So now that we've taken the approach, we look at figures first. We don't look at the question, and we don't look at what they tell us. We always look at the figure first. It creates it gives yourself a sense that you're analyzing the illustration independently, so you're not going to become biased by the question. The question can start leading you astray, whereas if you just focus on the illustration first, chances are higher of getting the answer right. This is just empirical data of my own and my own way of thinking as well. And I've worked with enough kids where once I move them into this kind of fashion of things, they can get the answer. In a lot of cases, whereas previously they would just led astray. Okay, there's not a lot of words to this example. So it says the graph of the line is shown. So here there we have it. All we have is the x and y is being labeled. The line doesn't have a name. So let me move this up so we can get some of the questions onto the screen. Just let me double check to see that actually happened. Yes, it did. So it says, what is the slope of the line? Okay, so there's a couple ways to solve this. First is to know what's a positive slope and a negative slope. And this is really a double check. So when a line goes this way, it's negative. And when a line goes that way, it's positive. Okay? So don't remember the both of them. This is why people get confused. Either remember this or remember this. If you remember this as a plus one, then the opposite way is not plus. And if you only remember this as a minus, then the other way is that. When people start trying to remember, students start trying to remember both. I'm not saying it's not possible, but there's no point learning two things. So just remember this is positive. And then you're done. So it says, what is the slope of the line? So you already have a clue in that the answer can't be C or D, right? The answer can't be C or D. It has to be A or B. So the question is, which one is it? So the slope of the line involves the rise over the run. And that's normally defined as the difference between the y's, y2 minus y1, over x2 minus x1. Right, sloppy, sorry guys. And then you'll just fill them in. So what we can take is two of the y's, right? And it depends on where. So we can just take some of the numbers and plug them in. So it's often handy to do it on the axis there, but I'm going to take, for instance, where it crosses the x-axis there. I get 0, 5, right? And I'm going to go down where that 3 is and do 1, 3. Okay, and those are my 2 points. So I'm going to subtract them. I'm going to get 5 minus 3, right, over 0 minus 1. And I'm going to get 2 over minus 1, or minus 2. So our slope there for question 17 should be B. All right? And if you want, we can visually inspect this, where we have, when we get into here, we're going 1 over and 2 up. 1 over and 2 up from the point here. Just if we just focus on the point of the line I'm showing on the screen, we have 1, 3, the bottom of that triangle, so to speak. And then where it crosses the axis is 0, 5. So we're going to go 1 over and 2 up, and we have a negative slope, right? So let me get this straight back to the normal shape it was in. Right, so far these are not really the sexiest examples, but you just go with the flow. Sometimes the easier, sometimes the harder. And what you want to do is psychologically prepare yourself, by the way, while a test is going. Because sometimes you can get a question, and then you get in a groove, and all of a sudden you get a whammy one, and you forgot something. So as you go to each question, whether the previous one was super hard, just normal, easy, super easy, whatever the case may be, just make sure you're on board. And remember, the problem with hard questions is they're hard, and the problem with easy questions is they're easy. And in enough cases, some of the easy questions are actually hard questions. So 17, 18. Okay, let me make sure 18 is fitting on the screen. Yes, it is. So 0.18 on a circle with a center minus 2, 4. What is the radius of the circle? So on this kind of problem, you want to draw these things. So I know I need to go up to 8. So what I'm going to basically do is set up an XY that will go to 8. So that'll be 4. That'll be 2. That'll be 6. And then we have what's in the middle of it. So that's 8. That's 4. That's 2. That's 6. That's 2, 4, 6, 8. This might be a little longer. 4, 2, 6. So we have 8, 6, 4, 2. These are minus. And then we're going to go up to here, about here, 4, 2, 6. All right. And if you want to, you could fill in the things here. So it says 0.1, which is here, 8, which is up here. So this is 1, 8. Is on a circle. So there's some sort of circle here. The circle could be here. The circle could be over here. So let's find out where the circle is. With the center that's minus 2, these are minus, right? Minus 2, 4. So that's the center. So our circle is something like that. Okay, I'm doing this freehand. Okay, so they want to know is what is the radius of the circle? That's from the center to here. Right? So what I'm going to do to solve this is to make it into a triangle. And if I can get this coordinate there, whatever that happens to be, then I can figure out the length of this and the length of this. And once I get those two, I could probably run through the Pythagorean Theorem to get what the hypotenuse is, normally called C, right? So what do we have here? If this drops down, we had 1/8. So that means our x here is 1. And over here we had minus 2, 4. So the y is 4, if I did that right. So we have 1, 4 and 1/8. So that means if we're 1, 4 and 1/8, then our distance here is 4. We have 8 minus 4. So this is 4. And if this is minus 2, 4 and this is 1, 4, our distance here is 3. So some of you at this point should know that there's something called the 3, 4, 5 triangle. So that means this would be 5. And that would turn out to be our radius. If we want to use the Pythagorean Theorem, we'd have c squared equals a squared plus b squared. Okay? And we get c squared equals 3 squared plus 4 squared. And c squared equals 9 plus 16. And that's equal to 25. So, and then we would take the square root of both sides. and we would get C equals 5. Right? Sorry, I'm using C for centi here, and also C for this, because that's what the formula normally does. It doesn't use H, because it'll be H squared equals X squared plus Y squared, and it's just easier to remember the formula. Again, these are conventions. What's more important is what the formula does and means. So I hope everybody knows what it is, including grade 8 kids again. So again, trigonometry, it ends up being more of a grade 9 issue. Although this isn't formal trig, we're not going totally deep into it on the SHSAT, although the full gamut of choices is always there. All right? So that's the kind of thing you have to deal with. Let me just make sure the stream is still running. Yeah, we seem okay. So this one's kind of a no-brainer that you just had to fill that in. So if you never saw an example like this before, please try and locate a bunch. They will use coordinate geometry to this extent. They're not going to, you don't really need to go deeper into doing circle things really than this. But again, there's no guarantee. So you should find some examples involving that kind of a thing, because they could also do this in reverse, where they might give you the center and the radius, and you have to determine if some of the answers are on around the circumference of the circle, right? Because this point here, right here, ended up being on the circumference of the circle, right? And they may also give you the circumference and the radius, and ask you for something like the point over here, because once you realize you can get the triangle out of it and so on. There is ways to get a distance formula here. I don't want to go there. It's just complicating things at this level. And the SHSAT doesn't really go that full mile, neither does the ISEE. Again, it's possible, but it's just worth avoiding it at this level for simplicity purposes. This works and it's reproducible. And if nothing else, the two ways can be used to double check each other. All right, so that's 18. 18 better be 5. 18 is C. Yep, 18 is 5. Okay, this comes up often in all the tests, obviously on the SHSAT and the ISEE. So let me make sure that's showing on your screen, because I might be blocking it with this thing. Yes, I am. All right, so let's get this guy out of the way. Let's move me out of the way. Can that show? No, it can't. Give me a second. All right, there we go. Nope, still not perfect. Okay, so Terry is planning a survey to try to determine the average number of hours students at her school spend watching TV. So this is a traditional, standard, conventional kind of a probability statistics question. They're always going to ask one of these, and it's going to be in exactly this form. And without looking at the details and the answers yet, what you're really shooting for is, what's the answer that will present the greatest population to conform to this? And what normally happens is, all the answers could be true, but which is the best? And you'll see what I'm going to say about that in a second. So Terry is planning a survey to try to determine the average number of hours students at a school spend watching TV. Which sample of students will give her the most reliable information about the students in the school? So it's not which will give her info about the students. They will all probably do it. They're mostly telling you that. But which is going to be the most reliable? So, for instance, her friends. Okay, if she asked only her friends, would she be able to determine the average number of hours students at a school spend watching TV? Yeah, if that's the only data she had, then that would be the only thing she would have to go with. So that would work. But is it the best choice? I mean, if you were if you were to cover up the answers and say, like, how can I get this? You would probably shoot for a random sample of all the students in your school. But first of all, you shoot for asking all of them. But if you can't ask all of them, you would certainly shoot for what's the best way to get the largest population of a random sample. So B seems really good here, and it's definitely better than A. Okay? C, all the people that show up to a football game. Well, a lot of schools, there's a lot of people who show up at football games, even if they don't like football. It deals with team spirit, hanging out with your friends, all this kind of thing like that. So C is a good choice. In fact, it's usually better than A, right? unless all of her friends is the whole football team and all their families and stuff like that. But B still overrules that because B is still everybody. C is really just football people or whatever's in that group of fandom, if you will, right? And a random sample of students in the library before school, D, has two whammies. First of all, it's only considering people from the library, which is almost kind of doing like A did, only have friends. And furthermore, before school. So there's probably nobody in the library before school because the school's probably closed. Now, some schools let the kids in for studying, and some schools have like a zero period where you kind of can roam around and stuff. But it's still a random sample, all right? And it's of a subgroup. So B seems to rule here. Yep, the answer is B. Okay? Okay, the next question is 20. Let me make sure that's fitting on the screen as well. Yeah, it is. So we're going to look at the illustration first. We have a four-sided figure. 3 angles are filled in, and 1 is a question mark. So they're probably going to ask us, what is the number of degrees of that angle, right? So there's a couple ways to do this. You need to kind of analyze things. So we have a four-sided polygon, which is a quadrilateral, also known as a quadrangle. Is it a parallelogram? No. Is it a square? No. Is it a rectangle? No. But it is a quadrangle and a quadrilateral because it has 4 angles on 4 sides, and it's a closed polygon. So let's see what the question is going to tell us here, because nothing more we could do except maybe choosing that angle. We could do it up front, or we could read the question. Often when I'm talking about these, I do it up front because I'm second guessing. But on the SHSAT, you have about 1.5 minutes to answer each question. So you don't want to second guess too many things and do the calculations for it, because that may turn out to not be the question. All right? So the measure of 3 angles of a quadrilateral are shown in the diagram. So we're being told it's a quadrilateral even. Okay? So it says, what is the measure of the 4th angle? All right, so you need to know something. You need to know what is the sum of the angles in a quadrilateral. Okay? That's super duper important. If you don't know that, you may not get the answer right. So if you don't know that, you can probably have to brute force some of the numbers in here. You know, try 45, try 50, try 70, try 75. And maybe you might add them up and figure, and all of a sudden, oh, wait, and at one point you get 360 and it bings in your head, bing. That's the sum of the angles of a quadrilateral. So there's a general formula too, which is that it's 180 times the number of sides minus 2. So in this case, it would be 180 times 4 minus 2. Whoops, we're not on the screen. Let me bring that over. Okay, and minus 2 here, and we get 180 times 2, and that's equal to 360. Okay, I talked about in another YouTube where if you do a square and add this on here, this is 360, this is 180, and you get 540. You can derive that from here because it means we had a 4-sided shape. That's now, if we get rid of this, we have a 5-sided shape. So we went from 4 to 5, and we added 180 to it. So it basically means that every side you add on, you get that. So it doesn't matter how you do this. You can also remember the number of, you need to know this is 180, this is 360, a pentagon is 540. There's a whole bunch of things you need to go through. So you can memorize these, you can do the formula, you can build it up. But normally they don't go deeper than a quadrilateral. So anyway, we have the shape. So we're going to have 110, 130, and 75. So we're going to get 5, 10, 1, 1. We're going to have 315. So we have 360 minus 315, and we get 45. Okay, so the answer should be A. 20 is A. Yes, it is. Okay, so that's how to do it numerically. Now, a bunch of kids are going to say that question mark is 75 because these are opposite each other. These are opposite angles. But because this is not a parallelogram, that rule doesn't work. So question mark can't be 75. So don't just go, oh, bing, bang, boom, with no calculation, go on to question 21. No. These are, because these opposite angles were not equal. Right? So we're still not sure what that is. So you can't, there's no quick hack to this one. And again, don't do, don't do this calculation in your head and feed it back in. Feed it back in. When you're done, do 110, 130, 75, and 45, and add them up. Even if you do it two parts, you might get 240 here, and this is 110, 120, and that becomes 360. You could do it that way, or just go straight. 5 and 5 is 1, 7 and 3 is 10, 14, 15, 16, 1, 360, all right? In fact, I just double-checked my answer on 2 ways. All right? Okay, 21. 21 is a doozy. All right, let me make sure. That I have space to handle this. Wait a second. All right, let me get clean paper, because this is going to be a doozy problem. Okay, this is going to kill a lot of kids. This deals with permutations, combinations. This is where a lot of kids just crumble. So, so this becomes maybe the hardest problem we're doing today. By the way, let's see what we have. Half an hour. I'm just going to, after this problem, I'm going to kind of float back and forth because I started 15 minutes late. So I might do only another 10 minutes of this. So let's just jump into here. So the 6-member debate team plans to send 3 of its members to a conference. How many combinations of 3 members are possible from the 6-member team? So we're specifically being asked that, told that it's combinations. So we're being asked for that. So let's just kind of start running through this. We have a 3-member team. Okay? So what we need to do is fill that in. Because normally we have 6 times 5 times 4. But that's not really what the question is. It's asking us about combinations. So normally we have 6 factorial over the 3 factorial, and then do 6 minus 3 factorial. All right? So it basically means this is the formula involved for that. And it's ugly to remember. So I did the 6 factorial. This is the 6-member team. This 3 here deals with the 3-member combo they're asking for. And this here is just these 2 numbers subtracted from each other. So it basically becomes 3 factorial, and a bottom. Okay? So if you expand that out, you get 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 3 times 2 times 1. And it turns out there's a shorthand to this, which is it's the permutation over the number of choices, factorial. So if we use the locations, we have 6 times 5 times 4 over 3 times 2 times 1. So this becomes 6. That cancels out, and we get 20. All right? And the answer better be B. Yes, it's B. All right? So you're best off not really memorizing this. For the general cases and more advanced grade 9 stuff, definitely while you're in high school, you're going to need to know this and play around with it and so on. But at this point, this is really all you need to know. And we're mapping these 3 here. That's how we got these 3 here like that. Okay, for the 3 positions, divided by what our choices are, factorial. Right? Factorial just means if we have 4 factorial, that's minus 1, minus 1, minus 1, all times each other. All right? Whoops. Okay, 22. All right, so we have an illustration. Let's make sure that it's showing on your screen right. No, it's not. So we have an XY coordinate. It looks like there's 3 dots there. We have something at 2, 1, 3, 4, and minus 2, 3. So it says the grid shows the vertices of a parallelogram. And if we go to the bottom, it says, which could be the coordinates of the 4th one? So here's the quandary with this kind of a thing. We have this, and I'm just going to kind of do this by eye. So these are the 3 dots they give us. There could be another one here, and I'm going to make these circles. That's if it's there. There could also be another one over here. That's if it's here, right? There could be another one over here, depending, right? If it looks like that, it would be that. Okay, another one could look like this. Okay, another one could look like that. And I guess there's another one. Where's there another? Is another one somewhere? No, I guess that's the 3 choices. So what we want to do is look at the answers and see which one might kind of fit into there. So can we get this all on the screen at once? Yeah, let me see. So minus 3, 5. Minus 3, 5 brings this too low if you look at it. Okay, we're doing this by eye at the moment. Minus 2, 0. Okay, it's the one down here, so that's too high. Then there's 0, 1. No, that probably just gives us a dot about right there. And then there's 7, 2. So that one seems about right. Okay, so we did this by eye. What question number is this? Let me just make sure I got the right answer. 22 is D, right? Okay. The alternative to doing this is to double check and find out, as we mentioned before, what's the length of this side? And is it the same as this? In other words, are these the same length? And are these the same length? And then we can find out for certain. And that's the problem with like the dot over here. If we drew it the other way, we'd have to measure and do that. So we did it by eye and it actually fits. And on your test paper, right? On your test paper, you're going to be able to do this easier than I did it. And here's kind of a little trick, if you want. Let me draw the 3 dots again. Ah, shucks, this is not on your screen. So let me draw the 3 dots again. If the answer was going to be D, you can confirm it. Because if you go over a certain amount and down a certain amount, this should also go over and down the same amount. So that's a cheap way to double check this. That whatever the length of this is, if this is 5 over and 2 down, I'm making these numbers up. You could actually look at the coordinates and see what they are. Then this has to be 5 and 2 down as well to get to that 4th point. And you can work that each way with the other points. Because in this case, I think they made it visually clear enough that this was the answer. But if the dots were actually closer and just off by 1, you could actually do it that way. Like I said, I mentioned ago, you could actually find the length of this and the distance, but that becomes harder. So really what you're going to do is a cheap way to getting the slope and making sure the slope of these are the same and that you end up in the same place. Okay? All right. Let's see. How much I need to get out of here before 11, I hope. Okay, 23 is a great question. Let me bring this back better on the screen. So this one can be solved in 2 ways. Actually, all of them can, so I want to keep saying that. Hello, Alex. How you doing? Welcome. Please like and subscribe and join in the fun. So this can be solved in more than one way. Here's the way I like to do it. So we have 4x minus 7 is greater than or equal to 9. Okay? So this is absolute value. If you don't know what absolute value is, you had better know what it is because you need to know this for the grade 9 SHSAT for certain and definitely for the grade 8 SHSAT. So what you want to do is, there's a couple ways to do this. You can spin off the 9 to something. I like to spin this off into 2 pieces, which is what you see, 4x minus 7, and then minus 4x minus 7. Okay? So that's going to give us two examples. We're going to get 4x minus 7 is greater than or equal to 9, and then minus 4x minus 7 is greater than or equal to 9. And then you just solve the both of them. Okay? So what we need to do this is add 7 to both sides. So we get 4x is greater than or equal to 16. Divide by 4 on both sides. And get x is greater than or equal to 4. So first of all, nothing funny happened here except for just doing that original mapping and going for it. This is pretty straightforward algebra at this level. So you know at this point the answer might be A. It probably is not B. It probably is not C. And it probably is D. Okay? So we're going to solve this. So we're going to apply the minus sign. So we get minus 4x plus 7 is greater than or equal to 9. All right? So we're going to follow the same thing now. Remember, we had to copy the problem right, do the mapping right, apply the negative sign, and now we're down to normal algebra again. So we're going to minus 7 from both sides. Right over here, we added 7, but we negated the whole expression over here. So we have minus 4x is greater than or equal to 2. And there's a couple ways we can do this from here, but we're going to divide by 4 on both sides. So we get x, and then we have minus a half. So because the last step was we divided by a negative, when you're getting rid of the coefficient off the last term, which involving the symbol, if it's a negative, you flip the sign. All right, so we get x is greater than or equal to 4, and x is less than or equal to minus a half. Okay, so A match that. A matches here, but A doesn't match there, right? Because x being greater than or equal to 4, this doesn't even include that. It's another part of it, right? Because if we did this on a number line, we'd have 4, and then over here, and this is dotted in. Yeah, this is for the 9th grade, but 8th graders should also know it. That's the position I take on this. And then x is less than, we have 0 at some point, and we have minus a half, and it's equal. So we have two solution sets here. All right? Because this example is normally the basic level that the SHSAT's going to take you on, even a grade 9. So it can't hurt to notice a grade 8. And there might be other questions They may not ask you this directly on the grade 8 SHSAT, but this might present a solution in your toolkit on the grade 8 problems. So as we know in a lot of these examples, there's more than one way to do them all. And so having this knowledge is helpful. And it's not extraneous. It's not asking you, I'm not telling you you should know calculus because it may end up being useful on the SHSAT. No, I'm not saying that. I'm just giving you a little tidbit that applies to both. Because I take the perspective that a grade 8 SHSATer should know all the grade 9 SHSAT questions and answers as well. And a grade 9 SHSATer had better because grade 8 questions are part of the grade 9 test. So there you go. All right, so the answer to 23 is D. Okay. Let me just show you an alternative way to do it, because some of you may have been taught other ways. Let me get a fresh piece of paper here. It's actually equivalent to what I just showed you, but it's just another way to do it. And the more, everybody thinks different and yada yada, and the more capability you have, the better off you're going to be. So what I did was I split this into a plus and a minus version of it. Okay? There's another way to do it, which is to split this into a plus and a minus version. All right? So basically we're going to have 4x minus 7 greater than or equal to 9, and then we're going to have a minus 9 version. So we're going to have 4x minus 7 and then a minus 9 over here. So I'm going to just leave that empty for a second because I want to show you guys something. So if we process this as we did before, we add 7, we get 4x equals 16 divided by 4 and get x equals 4, all right? Sorry, we're going greater than or equal to here. So this is the same answer we got before, all right? Because this is the fact it's the same basic problem we started from. So we're going to go over here. We're going to ignore the sign for a second. The less than equal sign I'm talking about, not the minus 1. So let's make us believe it's equal for now. All right? So we're going to add 7 to both sides. And we're going to get 4x equals minus 2. And then we're going to divide by 4 on both sides. And we're going to get x equals minus a half. So if you notice, we end up with the same number, the minus a half. But this is why the sign is important. So when you get to two forms of this, you have to flip this sign in the beginning. On the example I did over here, I flipped the greater than or equal sign at the last step because I did the division. On this one, you have to do it on the first step because I divvied this up to plus or minus. In this one, you're dividing this up to plus or minus. So since we originally started out as greater than or equal to, we're going to end up with a less than or equal to. And this should be the same answers we got before, and you're going to find out that it's D. There might even be more ways to do this, but these are definitely two of the most standard ways to do it. And in both cases, you have to remember to do this. I just like to do it the other way. My personal preference is this way, and I'll tell you why. Because if I was presented with the problem without the absolute value sign, in other words, if this was the problem, somebody told me solve this, I would have to flip the sign at the end. So I just want to stay with my own convention. That's my own personal mental image of this. So I kind of like to do it there, and I don't normally do this way, and I probably was never taught this way originally, which might be why I'm biased to the other way. But if you're taught this way, just remember, in either case, you got to flip a sign. And the moral of the story here is, whenever you have some absolute value thing and some expression, some relational operator, and then another expression, that you're probably going to be flipping signs at some point. So just stick that at the back of your mind, that I should be flipping a sign normally on an inequality. These are called the inequalities. So especially when it involves the absolute value sign, that's what's going on there. 23, so let me bring this out of the way. Okay, 24. This kind of question probably doesn't end up on the SHSAT, but it's something you're supposed to know for years now. And it involves something that you may have no idea what it is, even in the grade 9. So let's look at what 24 is talking about. Let me make sure I got the answer right. Yeah, okay. So what type of number could not result from the difference of two irrational numbers? Irrational. So we have integer, rational, irrational, complex. So a lot of you probably do not know what a complex number is. Okay? Some of you may think you know what an integer is, and that's probably sufficient here. And difference. Difference is a testing term, and it's also a math term. Difference means the subtraction. So they're asking what type of a number could not result when you subtract two irrational numbers. So the normal definition of a rational number goes like, if you could say A over B, and that makes sense, then that's good. Okay, so this is rational. Irrational is something like the square root of 3, or pi, okay, where you can't express it as a fraction. All right? And a complex number involves a real and an imaginary part. We all know something like 4, which actually gives us plus or minus 2. But what if I had the square root of minus 4? All right? How do I get that? So this becomes more complicated. Because it can't be 2 and it can't be minus 2. So we get something called 2i, or minus 2i, right? Where I represents the square root of minus 1. So we can spin this off into two parts. The square root of minus 1 times the square root of 4. Because let me write that better. The square root of 4 is the same as minus 1 times 4. And when we have something like this, we can split it. The square root of minus 1 times the square root of 4. And this becomes 2. So if this is I, we get 2i. All right? So there's things like that. So which could not result from the difference of two irrational numbers? Well, I gave an example, something like pi. Right? So if I have 2 pi minus 1 pi, so at this point, if you don't know like the answer immediately, you're going to test numbers. You're going to use kind of low-key small numbers and just test them out. So if I have 2 pi minus pi, I get 1 pi. So that's still an irrational number. So could that be the answer? But not necessarily, because if I have pi minus pi, I get 0. So that could result in an integer. They're not saying must. It's saying could, right? So, so A is possible. Could a rational number be possible? Yeah, for this exact same reason. Okay? Could an irrational number be possible? Yes. I just gave an example of the 2 pi minus pi. Still ends up being pi. So the answer is a complex number. So you could solve this without even knowing what a complex number is by knowing that it can't be A, it can't be B, and it can't be D, and the freak one turns out to be C. Okay, you may not know 100%, but if you don't know what a complex number is, this is kind of what you're doing here. All right? So the answer there would be that. So let me see here. What else we got going on here? Should we do one more? Nah, I'm going to call this a day because I was supposed to be out of here by 11. It's actually past 11. So we're going to continue on with this. I might do another one tomorrow. I have to see. I have something else going on, so I don't know if I'm going to be able to feed it in here or not. So what I'm trying to do is just go through these problems calmly, without a lot of mayhem and theater, and just focus on what some of the topics are going to be. I have a plethora of other YouTubes that go through a whole ton of other different kind of problems. Remember that the grade 8 SHSAT may have grade 9 problems on it just because they're harder. And the grade 9 problems definitely have grade 8 problems on them. So again, both whoever you are needs to be doing everything. And you just want to be doing some more problems. But again, do it methodically. Figure out what your strengths and weaknesses are and go for it. Hopefully everybody's having a great weekend. There's 69 days left to the SHSAT, so that's about 10 weeks. So pace out what you guys are doing, and have a great day. Please like and subscribe. Thanks, guys. Bye.